Okay, so the example we're going to give is how could you build a service for something like a Lime bike service where you can rent a bike, you go out there with your phone and you can unlock the bike, take it for a ride, dump it, and then pay. It sounds simple conceptually, but there's a lot of software that goes into building that, right? So the way that this works with Eventual is you simply describe that service, which we call write your requirements, right? Describe that in natural language. We'll just show that very quickly. So here's a document that describes the different users of the system, the different actions that they can take, for example, creating an account and registering a payment method, and all those different commands that you might need to do. What are the ways we need to read data from the service? And finally, what are the workflows that need to run? So, for example, at the end of a ride, process the payment, lock the bike, and send a notification. So this is a natural language description of a service such that business folk, product people, and engineers can all collaborate and understand what's going on together. And then the next step is we take that document, which we call the requirements document, and use AI to do the low-level technical design. Right? So here we're just showing one, which is the finalized ride workflow. It's going in and saying, okay, when a user returns a bike, we're going to run this workflow. Here are the input properties and their data types, and here are the output properties and their data types. And then what are the low-level nitty-gritty steps that need to be done here? So, for example, process the payment, but it could fail or succeed, right? So what happens when it succeeds? What happens when it fails, etc. So it goes into thorough details, and then once it gets done with that, another agent comes along and reviews it, right? So it says, no, this is not approved, here's some feedback. So a sort of back and forth analysis automatically to reach the level of stability, consistency, and quality. So once you have those designs for each of the components, another set of agents goes on and implements the code, right? So what you'll see here in the next step is, in parallel, we're generating all the code files that implement that service. So different entities and events and all these different things implemented as TypeScript files. And these files will deploy to AWS at the end, which we'll show. We'll just get to the end of this. Like you can see all the files. Take a look at them. So here's one. So this is your relational database schema. So we've got a bike model with all these attributes of these relationships. We've got the rider, we've got the reservation, etc. So this is how you store the data from that service. And then we use our framework, which is the Eventual Cloud Framework. So this is your transactional system for modeling bikes in DynamoDB, and zip around and we can take a look at an event. So every time an account's created, we're going to log these attributes out. We can put that in our data lake, or we can put that wherever we need it to be. We then move on and we can look at the queries. So automatically generated command that implements what's called the get bike query. So this is how you get a bike, handle the errors, etc. And then same for adding data to the system. So here's a transaction for adding a bike into the system. Set the data, emit the event. All this is generated from AI. And finally, a long-running workflow implemented using our workflow primitive. Process the payment, lock the bike, and then send a notification. And you can see how the way that I'm saying it matches with the business requirements we said before. In the business requirements, I said process the payment, lock the bike, and send notification. But you can see the AI filled in the complex technical details for us without us, an engineer, having to do that. So that's sort of the value of the business requirements being written in natural language. Now, the last step is actually making it so it can work, right, and deploy to AWS. So we run this eventual deploy command. This converts that code into an infrastructure configuration with all these complex details. So we'll get to it in a second. These are your IAM policies, your roles, your tables, your databases, your functions. So it bundles up all the code. It starts provisioning the infrastructure. So you've got IAM roles, queues, buckets, policies, functions, etc. So we automate the entire configuration of the service on AWS, and the only input was that document describing the service in natural language. So much of the labor has been taken out and automated by AI, a combination of AI and our framework called the Eventual Cloud Framework. So that's the end of the demo. Thank you so much.